Alright, let's talk about linear inequalities. This question says a photography studio charges customers a flat setup fee of $40 plus $15 per hour for photo sessions. A client wants to book a session for 8 hours but has a budget limit of $100. Which inequality best describes this scenario? So we can see that the flat startup fee is $40, right? That's not going to change no matter how many hours the client books. So that's sort of like our initial or starting amount. So if we think about writing a linear equation from this, or I know this is inequality, but if you recall writing linear equations in the form y equals mx plus b, our flat startup fee, our initial amount, would be our y-intercept, and $15 per hour. So every hour more that we book, the cost increased by $15. So that would be our slope, right? If we wanted to write an equation based on this situation, we could write it as 15h, because that's the number of hours, plus 40, right? Because again, every time the number of hours increases by 1, the total cost increases by $15, right? And then 40, that's our initial startup fee. That's not going to change. Now, if we were writing a linear equation, we would just write y equals 15h plus 40 and we would be done. But we're not writing an equation here, we're writing an inequality. And we were told that the constraint that we have is that the customer has a budget of $100. That means that this total cost that they're spending on the studio, that has to be less than or equal to $100, because they can't go over $100. So then this would be our inequality. If we go to the answers, that's going to be this. No, not this one. This one switches the 15 and the 40. It should be this one. 40 plus 15h is less than or equal to 100. Okay. This next question says a bakery operates 2 ovens for baking cookies. The first oven has a 25% success rate for perfectly baked cookies, while the second oven achieves an 80% success rate. To meet daily orders, the bakery needs to produce at least 300 perfectly baked cookies. Which inequality models this situation where P represents the total cookies baked in the first oven and Q represents the total cookies baked in the second oven? Okay, so we can see that the first oven has 25% success rate, and the the total cookies baked in the first oven is P, right? So if we think about it like this, let's say that P is equal to 100, equals 100. And we know that the success rate of this first oven is 25%, right? So if we bake 100 cookies in the first oven and it has a success rate of 25%, that means that only 25% of 100 are going to be usable cookies, right? So we would do 25% of 100, or you can say 0.25 times 100 if you want to take that percent, right? Which is going to be 25. So from the first oven, in that case, there would be 25 usable cookies. Now, I, just came up with a random value for P. I said that, what if P was equal to 100? But it doesn't have to be, right? So we need a way to generalize this. We would say that, notice how over here we multiplied 0.25 times our p-value, right? 100 was our p-value. So we can say that if we want to find the number of usable cookies from the first oven, we would do 0.25 times p. Okay, now for the second oven, it had an 80% success rate, 80% success rate, and the number of cookies that were baked in the second oven were Q. So just like before, for example, if Q was equal to 200, then we would need to do 80% of 200 to find the usable cookies. And, that would be 0.8 times 200, which should be 160, right? But again, if we want to generalize this, then we would do 0.8 times Q, or the number of cookies baked in the second oven. So the number of usable cookies coming out of the second oven is 0.8 times Q. And if we add the number of cookies coming out of the first oven, the number of usable cookies coming out of the first oven, plus the number of usable cookies coming out of the second oven, this is going to give us the total number of usable cookies from both ovens, right? Now, we were told that the bakery needs to produce at least 300 perfectly baked cookies. That means that the total number of cookies from the first and second ovens has to be greater than or equal to 300, because at least means 300 is a minimum, but it can be more than that. That's fine, but it cannot be less. In the previous example, the budget was $100, so we said that the total cost has to be less than or equal to 100. But in this case, our minimum is at least 300 perfectly baked cookies. So we would do greater than or equal to 300. So if we go to the answer choices, looks like that's going to be A. Okay, now next one. The point x comma 46 satisfies both inequalities in this system. Which of the following represents a possible value of x? Okay, so if x comma 46 satisfies both inequalities in this system, that means that if we go through each answer choice, let's write this down actually. Okay, so what this is saying is that we have this system of inequalities. We have y greater than 22 and 3x plus y less than 25. We're told that the point x comma 46 satisfies both inequalities, right? And they gave us answer choices, right? We said that it says that a is -8, b is -3. Let me check the other one. C is 2 and D is 7. Okay, so we have C is 2 and D is 7. So what we can do is, let's start by plugging in -8 for x, right? If we plug in -8 for x, then our point becomes -8 comma 46. Now what we can do is we can test this point and see if it satisfies both inequalities, right? So for the first inequality, y is greater than 22. If we plug in 46 and we get 46 is greater than 22. So that checks out, right? That works. Okay, now let's look at the second inequality. 3x plus y is less than 25. So I can do 3 times -8 plus 46 is less than 25. Does that work? Let's see. -24 plus 46 is less than 25. If we add -24 plus 46, that should be 22, I think. 22 is less than 25. So that actually also works, right? So this first answer choice A, where x equals -8, that should work, right? So we would go with A. But just to see, how an incorrect answer choice would look like, if we try B, right? X is equal to -3, our point becomes -3 comma 46. So we test both inequalities once again. The first one, y is greater than 22. 46 is greater than 22. That works. Okay, now the second one, 3x plus y is less than 25. So I plug in -3 for x and 46 for y. And we can see that -9 plus 46 is not less than 25, right? If you do -9 plus 46, that's going to end up being 37, right? 37 is not less than 25. So then this point here does not satisfy the system of inequalities. So for a point to satisfy a system of inequalities, it has to work with both inequalities, right? In this case, -3 comma 46 does not work with both inequalities, so it would be incorrect. Only answer choice A actually works with both inequalities, so that would be our answer. Alright, so let's use -8, and we can see that's correct. There's also a way to solve this one using decimals. It's easier to do. You can see that if you graph the inequalities that you're given and then you plot the point x comma 46, which is, they said that x comma 46 is a point that satisfies both inequalities, right? So you graph both inequalities, you plot x comma 46, and then you go and you replace x with each answer choice. So you start off with replacing x with -8, then -3, then 2, then 7, just like we were doing algebraically, except this time Desmos does the work for you. You want your solution to lie within like the overlapping region of both inequalities. So if we look at this graph, right, you can see that I've plotted y is greater than 22 in blue and 3x plus y is less than 25 in red, right? These are the two inequalities, and for a point to be a solution, it has to lie within the shaded region, within the overlapping region, right? So you can see that negative 8 comma 46 does lie within that region. If I went with negative 3 comma 46, it lies only within the region of y is greater than 22. So it only satisfies y is greater than 22, not the other one, right? And same thing with, if I did like 2 comma 46, that doesn't work, or 7 comma 46, that doesn't work either, right? The only one that actually works is negative 8, because that's in that overlapping region. So in this case, Desmos would probably be easier to do, but let's look at this one. It says a librarian is organizing books on a shelf that is 84 inches long. The thickness of each book varies between 1.5 and 2.8 inches depending on the type of book. What is the range of possible values for K, the number of books that can fit on this shelf? Okay, this one is interesting. So let's see if we can sort of visualize this so that we don't get tripped up by this question. We can see that um, the shelf is 84 inches long. So this is a bookshelf, 84 inches. And you can fit books on this bookshelf, right? And so on, right? We're told that the thickness of each book is between 1.5 and 2.8 inches, right? So maybe this one is 1.5, this one is 2.0 or whatever, right? But the thickness is between 1.5 and 2.8. So I can write that uh, okay. Now, what is the range of possible values for K, the number of books that can fit on the shelf? Okay, so let's think about it like this, right? The maximum thickness is 2.8 inches, right? Now, let's say, just for example, that all of the books were a thickness of 2.8 inches. That would mean that, like, and then I asked, how many books can fit on the shelf? Well, we have 84 inches of real estate to put the books on, right? And each book is 2.8 inches, we would do 84 inches divided by 2.8 inches, right? 84 inches total divided by 2.8 inches per book. Let's see what that would be. 84 divided by 2.8 would be 30, right? So if it was the case that all the books are 2.8 inches, then there's 30 books that can fit on the shelf, right? And remember, that's the case where all the books are maximum length, right? So we would say that this is like kind of the shortest, or sorry, the smallest possible amount of books that could fit on the shelf, right? Imagine if each book was like this long, right? Or this thick, then not many books could fit on the shelf. And that's the point. This is the lower bound for how many books can fit on the shelf. This is the lowest possible amount if each book is a maximum thickness. Now let's look at if each book is very thin. If each book is the minimum thickness, so that's 1.5, right? So if I said, all right, each book is 1.5 inches thick, how many books can fit on a shelf that's 84 inches wide? Well, I would do 84 inches divided by 1.5. And let's see what that would be. 84 divided by 1.5 would be 56. So the maximum number of books that can fit on the shelf is 56, and that's if they're all very thin, right? So this picture here represents, if the books are all very thick. Let's say I drew another example, but this time all the books are very thin. You can see that more books can fit on the shelf, right? So that's the point. The highest or the largest amount of books that can fit on the shelf is 30, and the sorry, I missaid that. The smallest number of books that can fit on the shelf is 30 books, and the biggest number of books that can fit on the shelf is 56. So I can say that the number of books that can fit on the shelf is between 30 and 56, right? So I can use that inequality to represent the situation. In this case, we're using K, so it would be K is between 30 and 56. That's going to be A. And there isn't really a way that you could, solve this one using Desmos, but this one says a freelance consultant earns a monthly retainer fee of W dollars plus performance bonuses equal to 15% of the total project value they complete each month. The consultant aims to earn between 2 and 5 times their monthly retainer fee, which inequality represents all possible values of the total project value P in dollars the consultant must complete to achieve this earnings goal. Okay, interesting. So they earn this monthly retainer fee of W dollars. So retainer is just, I guess their base pay, right? Just for having them on. And then they also get performance bonuses that are equal to 15% of the total project value that they complete each month. And they want to earn between 2 and 5 times their monthly retainer fee, which was W, right? All right, so let's think about how we can approach this problem. They earn W, which is the retainer fee, plus 15% of the project value, right? P. So I could rewrite that as W plus 0.15 P. That's the total amount that they earn in a month, right? Their goal is that their total should be between, they said that they want to earn between 2 times the monthly retainer fee and 5 times the monthly retainer fee, right? So their total is between 2W and 5W. This is between 2 times their monthly retainer fee and 5 times their monthly retainer fee. Okay, now we just said that their total amount that they're earning is W plus 0.15P, right? So I can say that 2W is less than or equal to 2W is less than or equal to W plus 0.15P is less than or equal to 5W. Okay, now if we go back to the question, what were they asking us? They were asking which inequality represents all possible values of the total project value P in dollars a consultant must complete in order to achieve this earnings goal. So in other words, what is the range of possible values that the project can be worth in order for them to actually get this much money, right? So we're solving this inequality for P. Let's think about how we can do that. Well, we've set up this inequality, right? Now we want to solve it for P. And although this is kind of strange, you can actually deal with this inequality just like you do with, other inequalities and other equations. Except this time we have 3 sides, right? We have this one, this one, this one. We're used to dealing with left and right, but the principle is going to be the same. So just like how if I have, an equation or an inequality with 2 sides, if I have an inequality with 3 sides, if I subtract something from one side, I can just subtract the same thing from all 3 sides and keep the inequality the same, right? So I want to take this, right? I want to isolate the p. I want to get p by itself, right? So because I'm solving for the values or the range of values for p. So I'll start off by subtracting w from both sides, or sorry, from all 3 sides, right? And that gives me w less than or equal to 0.15p less than or equal to 4w. Okay, now I just need to divide all 3 sides by 0.15 so I can get rid of this, right? So I'll, do that. Okay, so over here, you can think of this one as 1w, right? So 1w divided by 0.15. Let's see, what is that going to be? That's going to be 6 point... Actually, no, sorry, I just realized. If we go back to the answer choices, this might be an answer. We might not have to simplify this. So let me just write it like this. W over 0.15 less than or equal to P less than or equal to 4W over 0.15. Let's see if that's an answer choice. It actually is, right? It's right here. So this should be our answer choice. Okay, nice. Okay, last problem. Which point x comma y satisfies the given system of inequalities in the xy plane? Okay, so we have y is less than negative x plus 5 and y is greater than 2x minus 1. So, and then we have, a bunch of points, right? So what we could do here to solve this, if we wanted to solve it algebraically, is we can take each point and just plug it into, each inequality and see if it works, right? Just like in a previous problem that we did, we have the two inequalities, y less than or equal to negative x plus 5 and y is greater than or equal to 2x minus 1. Answer choice A is 0 comma 6. So let's see, if I plugged in 0 comma 6, I would get, if we start off with this one, right? 0 for x, 6 for y, I get 6 less than or equal to 0 or negative 0, whatever, same thing, right? 6 is less than or equal to 0 plus 5, or 6 is less than or equal to 5. That's definitely going to be incorrect. So if it doesn't satisfy one inequality, then we know that it can't satisfy both. So we can just go to the next one, right? Next one is So it's not going to be this one. Next one is 2 comma 3. Let's see. 3 is less than or equal to negative 2 plus 5. 3 is less than or equal to 3. That works, right? So it satisfies the first one. Let's try the second one. Y is greater than or equal to 2x minus 1. 3 is greater than or equal to 2 times 2 minus 1. 3 is greater than or equal to 4 minus 1. 3 is greater than or equal to 3. That works, right? So that would be our answer. I think we could just go with 2 comma 3 because that one actually satisfies both inequalities. So we can select B. And we can see that that's correct. And there is potentially a quicker way to solve this one using Desmos. If you graph both inequalities, you can see plot both inequalities and then plot each point. The correct answer should be in the overlapping region just like before, right? So if I look at this graph, right, you can see that the inequalities are plotted, right? And the solution should lie within this overlapping region, right? You can see that the point 2 comma 3 actually lies uh, over here where the actual lines intersect, and that's actually okay for this problem because the lines are included in the inequality, right? This should be yeah, the formatting got a little messed up. This is y is less than or equal to, and this is y is greater than or equal to, right? So you can see that because it's less than or equal to and greater than or equal to, that means that along the line actually counts as a solution, right? So that's why it's fine for this point to lie over here. Let's say that one of these was actually not less than or equal to, instead it was less than, right? Y is less than negative x plus 5. This would actually not be okay because any point that lies along this dotted line or dashed line does not count as a solution to this first one. For the second one, it can lie on the red line because its y is greater than or equal to. But for this first one, any point that lies along this dashed blue line does not count as a solution. It has to be in the shaded region. So if it was the case that we had this inequality instead, then um then 2 comma 3 wouldn't work. It would have to be well within like this actual shaded region. But we're lucky for us. We can actually just plug in if sorry, since it is y is less than or equal to, any point along this line actually counts, right? So 2 comma 3 would actually work. And we can for example plug in 0 comma 6, which was answer choice A. Let's see where that's going to end up being. You can see that that's within the red shaded region but not within the overlapping region. So 0 comma 6 satisfies one but not both inequalities. That's why it's incorrect. And if you tested the other answer choices, you would see that none of them actually satisfy both inequalities.